So Allan went to MIT. Let's pass this on down. Yeah. Went to MIT and he graduated a year ahead of Burton Richter, who gives his regrets he couldn't be here tonight. He's got a medical issue, but he'll be seeing this on the internet. Allan, after graduating, had a Fulbright scholarship in Rome. Was that about
before
right?
that, I went to the University of Illinois.
Get a little closer.
At MIT, I worked at the synchrotron lab. They had a 300 million volt circular synchrotron supported by the Navy. That was, the East Coast seemed to have a lot of Navy. And then we were a little bit jealous that at Berkeley, that was supported by DOE, they had a lot more equipment than we had. But my first job went to the University of Illinois, and that was the lab there, the Betatron lab in the physics department, was funded by the state of Illinois. Actually, it's interesting, the name Loomis, that
keeps popping up.
the department head was J. Wheeler Loomis. I don't know whether it was a relative, must have been, because he was at the RAD lab, and he was, I guess, a very powerful figure in the RAD lab.
So then you joined SLAC.
Yeah, I went to Rome. They had a bigger synchrotron, and before I went there, I had gone to a physical society meeting in Chicago, and I heard a talk by Beef Panofsky.
We'll talk more about
that. He talked about a research line that he wanted to do scatter electrons off protons, but not elastically, but having lost some energy. And I thought, wow, that's wild. And he talked about bigger accelerators. He said, well, the biggest accelerator you can make is put a accelerator around the equator, and if you use the Earth's magnetic field, you could get and I thought, wow, that's thinking big. But then I went to Rome, and when I got an offer to come to SLAC, I jumped at it. And I came, I wasn't really very involved in building the accelerator, but I was getting ready to do experiments, and different groups had different techniques for doing experiments. Dick Taylor, who came out of the Hansen lab, wanted to work with Panofsky on this inelastic scattering, and Panofsky decided that if he was, I guess Ginston was supposed to be the director of the lab, but he decided that he would stay at Varian. And so Panofsky became the director.
So at Stanford, tell me a little bit about the physics department and how they decided to implement this lab and the arguments back and forth.
Well, there was sort of a big fight in the physics department. Already with the Mark III accelerator and Hofstadter getting the Nobel Prize for scattering electrons off protons in elastic scattering, where it just bounced off, he could see that the proton was not a hard ball, because you'd get much bigger scattering, that the electrons sort of went through the proton and had more small angles. So he actually, by using the number of electrons that get scattered at different angles, could then determine the size of the proton. And then people were interested, well, if there's size, what's in there? And, well, you needed a bigger accelerator to get higher energy, shorter wavelength, to be able to probe inside. So the idea of the bigger accelerator came up, and to build it, you needed a lot of money. And that meant that, in Panofsky's view, that it had to become a national laboratory and not just part of the physics department. You wouldn't get the money from Congress, $114 million to, in those days, that was a lot of money, billions today. To do that, it had to be a national lab, which meant that anybody in the country could come and use it.
In fact, anybody in the world.
And then anyone in the world. And whereas there was Bloch and Hofstadter who said, no, we want to run that. And so there was a split. So they decided that it would not be a part of the SLAC, would not be a part of the physics department. It would be a separate department in the university. I guess at that time, we wanted to get graduate students. We couldn't get any from the physics department. They wouldn't send.
There was no communication back and forth there.
They didn't talk to each other. So we got from every university around except Stanford.
Yeah, in fact, my grad school roommate went to Harvey Mudd, and he was a PhD student at SLAC.
Yes, yes.
When I was his roommate.
We had the faculty, and theses were given, but they weren't from the physics department. Well, you know, it's after some number of years and retirements, they kissed and made up, and we got lots of Stanford graduate students.
Well, you were there in the early years with Panofsky. Tell us a little bit about what he was like as a manager, as a director, as a scientist.
Well, Panofsky.
And they called him Peef.
Peef, of course.
Peef was a remarkable man. He was, his father was a professor in Hamburg, Germany. And he was a professor he invented the field of art history. And there were two, I think they were twins, not identical twins, that came in the 30s to Princeton, and where the father became a professor, and the two sons at age 15 entered Princeton, and the brothers there was the smart Panofsky and the dumb Panofsky.
Yeah. Tell us why they separated
The
those.
dumb Panofsky got 1 B. And all the rest were A's. The smart Panofsky got all A's.
That was Hans Panofsky. Wolfgang was the B+ guy.
And Pete was a little man, quite energetic, and such a nice person. I mean, stories. It isn't like Sperry that they closed at 5 o'clock. Everybody was there late at night, and weekends as well. And one weekend, his secretary had to do something, so they got a temporary. And when he came in, he would wear just a plaid shirt, and she looked at him and thought he was the janitor. So she asked him can you take out the empty the wastebasket? So he did. He then took it out. And then she was a little surprised that he came back in and sat down at his desk.
But he sort of used management by walking around way of working with
That
the
was
staff.
something that was absolutely wonderful. That I was working on a project. We developed a new detector for particles called the streamer chamber. It was you had a gas, and you put a high voltage pulse on 2 electrodes, and you could start from the electrons left behind the trail of a particle. The electrons would start avalanches, but the pulse was so short that it stopped. You didn't get a full spark, and you look through the electrode, which was a mesh. And so we developed the 800 kilovolt pulsar on 20 ohms, the pulse
George, I'm here.
duration of 12 nanoseconds.
I'll put you on the
So it was a
background
lot of
here, and you can hear
current.
what's going on. We got
It was
Allan on right
a
now.
lot of technology. In any case, while we were there and things would break, and every week, Pete would come around and ask us,
Say it again.
how's it going? What are your problems? And sometimes the problems were technical. And then he'd say, well, why don't you try this? You know, there's a director. He's not supposed to be in the nitty gritty, but he was awfully good. And he could tell you, well, go in that direction. And sometimes you needed more money to get some special thing done, and he'd make you give him a spiel about why you needed it and couldn't you do it a different way, but if he was convinced, you got the money.
He's spring for the bucks.
That's right. So he walked around constantly, and
Yeah, George, we'll be about
everybody was
another 8 or 10 minutes. Just stand by, and I'll.
everybody
I'll call you when we're ready.
really appreciated it and kept people coming in nights, weekends to run the project.
So tell us a little bit about the big science that you were involved in at the detector and just a
Well,
snapshot of what
yeah,
happened with
there
this
were-
lunar accelerator.
I got close a couple of times, but didn't hit the jackpot. But the people who hit the jackpot, Taylor, who became the head of the experiment when Panofsky said the director of a laboratory must not be involved in an experiment because that's a conflict of interest. So he stepped back, and Taylor took it, and they built a set of magnets. They scattered electrons off a target, and they had a set of magnets that reduced the trillions of electrons being scattered to the small number that you could count down a channel, and did the number that were scattered at different angles and different energies. And with that, they could see that it seemed there was a concept called scaling that was explained. Nobody understood what that meant, but Dick Feynman from Caltech came up one weekend, and people explained the results. Why are we getting this property called scaling? And he thought about it and said, oh, there are little particles inside the proton. There are little hard things. That's quarks. Quark theory came a little bit earlier, and the particles they were finding seemed to support it, but there was no real hard evidence. That produced the real hard evidence that there was something inside the proton, and quarks came up.
So Allan is one of the many people who worked at SLAC on the big science stuff. There was quite a cadre there, very collegial atmosphere working there at SLAC of scientists from all over the world.
Yes, we had them from Europe, from Japan, from Asia,
Armenia,
in
Georgia.
general, and formed great friendships. I mean, I went to Europe multiple times, and those people came here, and so it's still one of the Nobel Prize winners, Martin Pearl, who had died last year, they had a memorial a couple of weeks ago, and people came from all over the world.
Well, where are you headed in a couple of weeks to do
well,
it? I hear you got work. Still working.
I'm retired, but I go in every day. It keeps me off the street, and my wife says, go there, don't be underfoot.
But I understand that China is paying you to come over there and spend some time with them.
So I'm involved in 2 experiments, and we have Chinese collaborators, and each institution has to do part of the instrumentation for the next experiment that we're preparing. And one of those projects hasn't made any headway, and so they asked me to come. I don't know whether I can help them. I'll find out.
Okay.
I'll give it a try anyhow.
Thanks, Allan.
For a second.
Sure.
This is a very quick thing. When I was in high school, my aunt taught math in San Francisco to Ernest Lawrence. So she took me over to see him, and he showed me his very first cyclotron, which I could have held in one hand.
Little guy.
Very small, but it proved that it was going to work.
A very close community in those days, and probably it still is.
What year would that have been?
No, I was in high school, let's say.
In 41?
31.
31, 41?
Boy, I don't even remember when I graduated.
You
from high
graduated
school.
in the late 30s, is that right?
Let's see, he was born in 26.
26,
so
36, 40, about 1938 or 40.
Yeah, something like that.
Is Paul Edwards here? Come on up with your parts, Paul.